Hello everyone, and welcome to the new episode of our series of solving LeetCode Daily challenges. And today we are going to solve a problem called add two numbers 2, which has a medium difficulty. So without further ado, let's move to the problem statement. We are given two non-empty linked lists that represents two non-negative integers. The most significant digits come first, and each of their nodes contains a single digit. We need to add the two numbers and return the sum as a linked list. And we may assume that two numbers do not contain any leading zeros except for the number 0 itself, which is quite logical. And let's look at the constraints. The number of nodes in each linked list is in range from 1 to 100, and it's guaranteed that the list represents a number that does not have leading zeros. Okay, so what can we get from these constraints? First of all, our number can be quite big. It will definitely not fit in standard data types like int or long or whatever, because it can have as many as 100 digits. So we need to figure something out to resolve this. And I'm going to explain two different solutions for this problem, because I think it's quite educational. Maybe it's not the best or the funnest problem, the most fun problem of all times, but I think it has a very, very good educational value. So, okay, we want to add two numbers, just like they taught us in school. So, remember when we were adding on the chalkboard and stuff like that? However, the problem with that is that we need to start our addition from the least significant digits. And our lists that represent numbers, they are given to us starting from the most significant digit, and they say it directly in the statement. So what can we do with it? We will deal with this problem in two different ways in our two different solutions. So let's first talk about our first solution, where we reverse the input lists. So suppose we are given a number like that, represented by a list. So we have a number 1609. We want to reverse this list to get to representation like this, so that the least significant number comes first. And we will do it iteratively. And suppose that we have processed some of the first digits in this list, for example, 1, 6, and 0, we expect that our result at this time will be equal to 0, 6, 1. So for each prefix of our number, we expect that our temporary result will be the reversed prefix. And naturally, when we will process the whole number, we expect that the result will be the whole number reversed. So at the beginning, we just start from the value of now, just to kick us off. Then we will take a look at the first digit, and we will simply add it to the beginning of the list. And now technically we have the first digit reversed, because it's only one digit. Okay, then we will take a look at the second digit, and we want to put it at the beginning of our reversed current result. So we will get the value of 610. Then we are going to take a look at the third digit, which is equal to 0. Once again, we want to put it at the beginning of our currently reversed list, and we will get 061, which is exactly the reverse of 160. And in the end, we will add the 9 to the beginning of this list, and we will get the whole number reversed, 9061, and in the end now. And that's exactly what we are going to implement. So today's implementation is in Java, and I think tomorrow's implementation will be in C++, so I think I will just mix them up. Okay, so let's look at how did I implement the solution number 1. At first, I reversed both of the numbers, and let's see how the reverse function is implemented. So at the beginning, our reverse number is equal to now, just like in here. Then I'm iterating through all of the digits, and I'm adding the Okay, it's the wrong solution. Okay, sorry about that. So once again, yeah, I'm reverse all of the numbers. Then, okay, I'm iterating through all of the digits in my current number, and I add the current digit at the beginning of the reversed by simply redefining reversed and stating that now reversed is a new list node that has this node value, and after this node value comes previously reversed list. So for example, in here, our previously reversed list was equal to 6,1. Suppose we are looking at 0, we will just add it to the beginning, and we will tell that the next element of this 0 is actually this 6 in this reversed. And that's basically it. Okay, so now we know how to reverse the number. We will reverse both of the numbers. We will introduce a notion of carry, because here, remember when we added on the chalkboard in school, we needed carry sometimes when the sum of two digits was bigger than or equal to 10. And then we're going to have a loop, which will continue either while we still have digits in our numbers, or we still have a carry. Then we will calculate the value of the current digit, and it will just be the sum of the current digit in reverse number plus current digit in the second reverse number and plus carry. And this get digit number is actually quite interesting because it's a safe get digit method. So I'm looking if my current node is equal to null, then I'll simply return 0. Otherwise, I will return node.value. And that's very useful because, first of all, our numbers can have different lengths. And it's possible that the first number still have digits and the second number no longer has digits. So we need to be very careful around this part of the code. And it's also even possible that both of our numbers no longer have digits, but we still have a carry on. For example, if we add 5 plus 5, then we still will have a carry on of 1. And in these cases, we want our get digit to return 0 for both of these cases. Okay, so I've calculated the current digit value. If it's bigger than 9, then I'm telling that the next carry is equal to 1, and I'll need to subtract the 10 from the current digit value. Otherwise, our carry for the next step will be equal to 0. And now I need to update the resulting list. And once again, since this current digit that we are calculating is the most significant digit so far, then we need to add it to the beginning of the resulting list. And that's exactly what I do in here. And in the end, I just move to the next digit in both numbers. And I return the result. So that was the solution number 1. What about solution number 2? So in the solution number 2, instead of reversing the list, we will keep all of its digits in an array-like data structure. So if you are coming from C++ background, you can either use arrays or vectors. And in Java, you, for example, can use, once again, arrays or lists. And I have chosen to use lists. So at the beginning, I'm going to convert both of the numbers to list, but I'm not going to reverse the order of digits. So they will be stored in the same order as they are given to us. And the method is quite easy. I'm introducing the empty list as a result. I'm iterating through our number, and I'm adding current digit to our list, and I'm just moving to the next digit. And in the end, I return the result. So all very simple. Once again, I introduce the carry, I introduce the resulting list, and once again, I'm iterating until my lists still have digits, or our carry is equal to 1. I will calculate the current digit value. Once again, this get last digit number works in a safe way. So if my current number is empty, I will simply return 0. Otherwise, I will return the last digit from this list representing the number. And once again, yeah, if current digit is bigger than 9, carry is equal to 1, and we need to subtract 10 from current digit value, otherwise carry is equal to 0. I add this digit to the beginning of my result, and then I remove last digit from both of the numbers. So, and if number is not empty, I simply remove, like physically remove, the last item from the list. And in the end, I return the result. And that's basically it. Okay, guys, what's the complexity of this solution? In both of these solutions, I iterate through all of the digits a couple of times, but this number of times that I iterate through them is constant. So the complexity is big O of n, where n is the length of our number. And actually, there is a third solution that I would like to discuss really briefly. So suppose you use some programming language like Java or Python, you can actually leverage the built-in classes for BigIntegers. So in Java, for example, it's BigInteger, and you can just convert your list of nodes to this BigInteger, then perform the addition with this specific class, and then convert back to list node. And yeah, I think it's important to think about such solutions because it would be useful to mention them during the actual technical interview, because it will show to your interviewer that you know about such facilities of your programming language. Okay, guys, thank you very much for your attention. I hope you liked these solutions. Hope to see you tomorrow for our next LeetCode Daily challenges. If you like my content, please press like, subscribe, and have a very, very, very nice day. See you around. Bye-bye.